Can you find integer solutions for an equation like 70x plus 60 equals 1? Most algebra classes say stop at fractions, but number theory reveals a secret. If the numbers are coprime, a solution always exists. We will unlock this powerful tool today. Linear Diophantine equations are puzzles where we must find whole number answers for variables like x and y, rather than decimals. The core principle relies on Bézout's identity, which guarantees that any integer can be written as a linear combination of two coprime integers. If you have two numbers with a greatest common divisor of 1, Bézout's identity asserts that there exist specific integers e and f such that a plus bf equals exactly d. This means the equation is solvable in integers if the right-hand side is divisible by that GCD. Let's look at a concrete example for the equation 17x plus 6y equals 73. Since the greatest common divisor of 17 and 6 is 1, and 1 divides 73 perfectly, we know immediately that infinitely many integer solutions exist. However, this method fails if the target number isn't divisible by the GCD. Consider 2x plus 4y equals 7. Here, the GCD is 2, but 7 is not divisible by 2, proving no integer solution exists. This clarity separates solvable puzzles from impossible ones. To actually find those specific integers x and y, mathematicians use the extended Euclidean algorithm. This systematic process breaks down the large numbers into smaller steps, until it reveals the exact coefficients needed to satisfy the identity x plus by equals g. Ultimately, Bézout's lemma tells us that all integers of the form x plus by are multiples of g. Understanding this relationship allows you to solve complex linear Diophantine equations efficiently without guessing random numbers. Now you know how to determine if an equation has solutions and find them. What specific Diophantine equation have you encountered in your studies? Share your examples in the comments below for a deeper discussion on number theory.